Section 12, we'll talk about springs, wells, and artesian systems. So there's a discussion question related to this section that you can go ahead and answer it once we're done. We know springs, we have a lot of springs in Florida. They occur where the water table intersects the land surface and natural flow of groundwater results. They may be due to the intersection of a perch water table and groundwater surface. So springs are important. Also, we have wells. Wells, what's a well? We are probably familiar and you heard about well, which are the opening bore. So people, humans, that we open the bore, right, into the zone of saturation and we withdraw the groundwater, and that may affect and may create roughly conical depressions in the water table, and that's known as a cone of depression. So the groundwater withdrawal of groundwater should be like done really carefully to prevent cone of depression. Let's watch this animation.
Groundwater cone of depression. The depth of a water table is frequently changed when groundwater is pumped from a well. Groundwater flows toward a well, so over time the level of the water table tends to slope down toward the bottom of the well shaft. Notice that as the two wells pump groundwater, the level of the water table falls until it resembles a downward pointing cone around each well. This is known as a cone of depression. A cone of depression will grow larger until the rate of groundwater recharge matches the rate of groundwater pumping. Notice that the cone of depression in the water table around the more heavily used well grows larger than the cone around the less heavily used well. The cone of depression around the heavily used well eventually grows so large that the water table drops below the level of the shallower well, which then goes dry.
And the last section will be talking about the artesian wells tap into the inclined aquifers bounded above and below by aquifers. For a system to qualify an artesian, the water in the well must be under sufficient pressure that can be rise above the top of the confined aquifer. Artesian wells may be flowing and non-flowing depending on whether the pressure surface is above or below the ground surface. And if you'd like to watch the video, I'll play the video for you, uh, and you'll be good to go to do the homework question that is selected from the concept checks.
Hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe what an artesian system is and distinguish between flowing and non-flowing artesian wells. This is an example of a flowing artesian well. Basically, all you have to do is drill a hole in the ground, and then coming up out of that hole, boom, is water. It kind of reminds me of the opening sequence of the Beverly Hillbillies, where Jed's out hunting rabbits, and he shoots his rifle, and the bullet pierces an aquitard, and that aquifer underneath holds not water but oil, and it starts oozing out onto the ground. It's the same thing here, except groundwater is what's flowing out of this hole. So let's take a look at two examples of these artesian wells. We're going to take a look at one that's very close to the recharge area, and then we're going to take another look at a second one that's further away from the recharge area. So let's go ahead and take a look at the first one here. We're going to zoom in on this area. You can see here that we've got an aquifer that's confined by two aquitards, one above and one below. You can see that the top of the groundwater there is the water table, and if you extend that water table off to the right, imaginarily through the aquitard that overlies the aquifer, that is what we call a pressure surface. And if you were to drill a well down and pierce that aquitard, the water would flow up in that well to that pressure surface. So the pressure surface is above the top of the aquifer, but the pressure surface is below the ground. So as a result, this is a non-flowing artesian well. Contrast that with this situation. This is more like the example that we looked at to start with. Further away from the recharge area and at a lower elevation, the pressure surface is actually above the surface of the Earth. As a result, the water in the confined aquifer wants to flow up through that well to reach that pressure surface, but basically it's hitting empty air there, so it ends up flowing out over the landscape. Gravity is more dominant than the pressure that's driving it out. This is the same exact principle we use basically to create water pressure in our houses. You know that there are these weird water tanks that are rising over the landscape in various places like UFOs. Basically what we do is we pump water up into those water tanks, and then that creates an artificial pressure surface. Then when you open the tap in your house, say to take a shower, the water flows out of that tap because it's trying to reach this pressure surface. Of course it never gets there because we don't let it flow out in high enough volume, and there's a lot of empty space for it to fill up before it ever got that high. That's why water comes out of your shower head when you turn the knob. Here's an actual example in South Dakota. Basically, we're going to take a look at a cross section from west to east across South Dakota, and you can see the Black Hills over on the left and the flat area of the Great Plains over on the right. So what we've got here is the Dakota sandstone, and this is an example of an Artesian system. And basically what I'd like you to do is imagine what the pressure surface must look like in order for this area over here to be an area of flowing Artesian wells. Well, okay, you had a minute to think about it. Probably what that pressure surface looks like is something like this. So it comes out over the landscape like that. And so if you're to drill a well here, piercing through this Cretaceous shale into the underlying Dakota sandstone, the water that is entering the Dakota sandstone from over here on the flanks of the Black Hills is going to try and flow up those wells and reach that pressure surface. Hopefully you got that correct. Thanks very much for your attention. This has been another Smart Figure.